Now we are going to do redox. Okay, whenever you are doing redox reaction, remember this equation, Zn plus Cl2 giving ZnCl2. Now, what is happening in fact here? You should consider the oxidation state of each species. Oxidation state. What is oxidation state? Oxidation state means it net charge on them. So the net charge here is 0, oxidation state 0, oxidation state 0. Now you know that when a metal reacts, it loses electrons, so it becomes positive. For a metal, it is always positive. So the valency of zinc is 2, so it becomes plus 2. Now for a non-metal, the oxidation state is always negative. Now the valency of chlorine is 1, so it is negative 1. So what is happening here? The oxygen state is increasing. Increase in oxidation state. You see? Decrease in oxidation state. Okay, now let us deduce the definition for oxidation. Okay, then we are going to do reduction. Let us see oxidation. What is happening to zinc? There is an increase in oxidation state. Okay, so in oxidation, there is increase in oxidation state. Okay, there is increase in oxidation state. Therefore, Zn, there is increase in oxidation state, so it is oxidation. Now, what is happening to Zn in fact? So Zn is becoming Zn2 plus 2 electron. So it is losing electron. Zn is oxidized and by the way it is losing electron. So what is oxidation? Oxidation is loss of electrons. Okay, loss of electrons. Okay, now loss of electrons. Now there is increased oxidation state, there is loss of electron. Later you will see that there is also two other definitions, is gain of oxygen atom, or loss of hydrogen atom. This is also oxidation. Okay, now we are more interested in the first two definitions. The first two definition is there is loss of electron. In an oxidation reaction, there is loss of electron, or you can say in the oxidation reaction, there is an increase in oxidation state. Okay, so Zn is oxidized to Zn2 plus. Okay, let us see what is happening here. Here, what is happening to chlorine. Chlorine there is a decrease in oxidation state. So there is a decrease in oxidation state. Okay. Now, in the examination, you write oxidation state. To save time, I'm making it like that. So what is happening to chlorine here? It is become negative, so it is gaining electron. because electron is negative. If it is gaining electron, so it will be becoming negative. Because electron is negative, Cl2 plus 2 electron means 2Cl minus. Okay, so in fact what is happening, it is a gain of electron. Gain of electrons. Okay, so this is reduction. Now opposite to this, it will be loss of oxygen atom. This is also a definition, or gain of hydrogen atom. As I told you, we are more interested with this part of the definition. In the examination, if you are told what is oxidation, you just have to say it is a reaction where there is loss of electron. What is reduction? It is a reaction where there is gain of electrons. So this is oxidation and reduction. Now let us talk on what is a reducing agent and an oxidizing agent. An oxidizing agent, a reducing agent. Now what is happening to oxidizing agent? So look here to this reaction. I'll always refer to this reaction. So what is the oxidizing agent here? What is the oxidizing agent here? So chlorine is an oxidizing agent. Why? Because Zn is oxidized. Zn is oxidized. Okay? Zn is oxidized to Zn2 plus. So if Zn is oxidized, so there should be an oxidizing agent in the system. So this is the oxidizing agent. Okay, for example, this is Mr. Zinc. This is Mr. Zinc. Mr. Zinc. Mr. Zinc is killed. Mr. Zinc is killed. Is being killed. So there should be a killer. There should be a killer. Okay, there should be a killer. If zinc is killed, he cannot be the killer. He is the victim. If zinc is killed, this one is a killer. He cannot be killed by himself. There should be a killer with it. Okay, so zinc cannot be an oxidizing agent because it is oxidized. Like zinc cannot be a killer because it is killed. So this is a killer. He killed Mr. Zinc. And this is chlorine. Okay, so oxidation. Oxidizing agent here is chlorine. Chlorine is oxidizing agent. Why? Because zinc is being oxidized. Why zinc is an oxidizing agent? Because zinc is an oxidizing agent because zinc is being oxidized. So an oxidizing agent is a substance. It is a substance. An oxidizing agent is a substance that is removing electron from a system. That is removing electron or gaining electron from a system. You won't be told in the examination what is an oxidizing agent. Okay, so here chlorine is an oxidizing agent. As you see, Cl2 is removing electron from a system, so it is reduced. So it is an oxidizing agent. It is removing electron from a system. It is a substance that is removing electron from a system. Right? How do we do a test for oxidizing agent? Suppose you have a test tube and you have a solution. We don't know whether it is an oxidizing agent or a reducing agent. What do we do? It is colorless. So remember, we have only two tests for the time being for your syllabus. Either we put acidified potassium iodide or we put acidified potassium permanganate. So it is an oxidizing agent, so I minus, 2I minus. If you put it in potassium iodide, it will become I2. You know I2 is brown in solution. Iodine is brown in solution, so this is colorless. So if you put acidified potassium iodide in an oxidizing agent, it will become brown. This is very important. Test for oxidizing agent. Likewise here, a reducing agent. It is a substance, a reducing agent. For example, Zn is giving electron. So it gives electrons. A substance that gives electron. That gives electron. Okay? To a system. Now, Zn is giving electrons. So it is a reducing agent. Now, how to test for a reducing agent? We take a solution of reducing agent. For example, you cannot take zinc. Zinc is solid. So, for example, we have so many reducing agents. Okay, for example, nitrite. Nitrite. It is a solution of nitrite. Sodium nitrite, for example, solution. This is a reducing agent. Okay, now if you put KMnO4 in it, dropwise, what will happen? The purple color will disappear. Purple color of KMnO4 will be decolorized. So what is the test for a reducing agent? We put acidified potassium permanganate because this is purple. It will become colorless. Do not be confused. Okay? Now it is a substance that gives electrons. Substance can gain electrons. Do not make confusion with this. Okay? But most of the time, you are not told in the examination what is a reducing oxidizing agent. Now, as a tip, all non-metal, most non-metal are oxidizing agent, and most metal are reducing agent. Because a metal will normally gives electron, no? This is why they are reducing agent, and non-metal will remove electron. I will remove electron, so they are oxidizing agent. Now, not only this, okay. Now let us see some reducing agent again. Very important in your syllabus. It is the sulfur dioxide gas. Sulfur dioxide gas. If you take a solution of acidified potassium permanganate, acidified KMnO4 solution, then we bubble sulfur dioxide gas dedans, it will decolorize. So sulfur dioxide is a reducing agent. Okay? Sulfur dioxide gas is a reducing agent. Don't forget this. This came out in the examination very often. Now let us talk about the last one. Instead of using acidified potassium permanganate, you can use acidified potassium dichromate. This is orange, and after reaction it become, if you put potassium dichromate with a reducing agent, it will become green. What is happening in fact? If we want to find the oxidation state of chlorine here, of chromium here, we just have to put potassium is +1. +1. For metal we put plus. For non-metal we put negative. The valence of potassium is 1. So it becomes +2. +1 times 2. Now this we don't know. We put it plus 2x. Now what is this? Valency of oxygen is -2, is 2. So for non-metal we put minus. So it is -2 times 7, it is -14. The overall charge is 0. So let us see this. 2x is equal to -12. -12, bring it other side, become 12. X is become +6. Okay, so here the oxygen state is +6. After putting it with the reducing agent will reduce its oxygen state and become +3. So chromium +3 is green. Don't forget this in the examination. Okay, now by the way, let us see the oxygen state of manganate here. What is happening to manganate? Okay, so manganate, KMnO4. If we want to find the oxygen state of manganate, potassium, the valence is 1, so it is +1. This is, we don't know the oxygen state, we replace it by X. This is oxygen is valence is 2, so for non-metal we put negative, so it becomes -8 is equal to 0. So this is X -7 equal to 0, X equal to 7. So the oxygen state of manganese, the oxidation state of manganese is 7, +7 here in potassium permanganate, and after when it is put with a reducing agent, it is reduced to Mn2+, and this is a very pale pink, right? A light pink color. Okay, so this is the reaction of, if you are told in the examination about the oxidation state, right? And this is for chromium, and happen with redox reaction. So what is redox reaction? It is a reaction in which there is both oxidation and reduction taking place at the same time. Okay, have fun now. So any problem, just contact me. Okay, bye-bye.